Okay, so the number 2b says, given that x plus 2y over 5 is equal to x minus 2y, find x is to y. So we have x plus 2y all over 5 is equal to x minus 2y. We can say over 1. Cross multiply. This is times 5, so we have 5 into x minus 2y equals x plus 2y times 1 is x plus 2y. I'll open the bracket. I have 5 times x is 5x. 5 times minus 2y is minus 10y equals x plus 2y. Now collect like terms. We have 5x, x crossing over is minus x equals, here we have 2y. Let's minus 10y come over here, it becomes plus 10y. 5x minus x is 4x. 2y plus 10y is 12y. Now we are asked to get x is to y. X is to y is the same thing as x over y, which means we are dividing by y. Y is down here. Therefore, divide both sides by y. I'll divide both sides by y. Y cancel y. I'm now having that 4x over y, as you can see here, is equal to 12. We need x over y, so to get this x over y, I will divide both sides by 4. So x over y is now 12 over 4. 4 here is 1, 4 here is 3. So x over y is equal to 3 over 1. Therefore, x is to y will now be 3 is to 1. That is the answer, 3 is to 1. So let's take another question. Okay. In question 3a, we are given this particular circle, and we are told that in the diagram O is the center of the circle, and the line BC is equal to line CD, you can see it, and the angle BCD is 108, so this angle here is 108 degrees. We have to find angle CDE, CD and E. So this is the angle we need to find, angle CDE. This particular angle, all the angles here. Now you cannot get this without making a construction, because there's nothing we can do here. So if I were you, I will join this particular point. If I join it, you can see that this is a diameter. Since here is O, center, this is a diameter, and this arc, this particular arc here, is forming an angle at the circumference. Look at the angle is forming at the circumference, this particular angle. And you know that angle at a semicircle is 90 degrees. Since this is a diameter, this is a semicircle, and angle at a semicircle is 90. Therefore, this angle here is 90 degrees. So you can write angle BDE equal to 90 degrees. Reason, angle in a semicircle. Angle in a semicircle. But consider triangle BCD. If you consider it, you see that this side and this side are equal, therefore this is isosceles triangle. I can call here x and can call here x. Since it is isosceles triangle, the base angles are equal. Therefore, the sum of the angles here is equal to 180 degrees. I can write x plus 108 degrees equals 180 degrees. X plus x is 2x plus 108 degrees equals 180 degrees. So 2x will give me 180 degrees minus 108 degrees. So 2x will give us 72 degrees when I subtract. So to get the value of x, I will divide by 2. This cancels out, so x is 36 degrees. That's the value of x. Therefore, this angle here is 36 degrees. But angle CDE that I'm looking for is from here to here, which is 36 plus 90. Therefore, angle CDE will now be 36 degrees plus 90 degrees. And that will give us 126 degrees. So let's take another question. In question 3b of 2020 theory part A, we are told that tan x is 3 and the angle x lies between 0 to 90 degrees. we are asked to evaluate this. We only know the value for tan, but we don't know the value for cosine and sine. Therefore, we need to work out the values of cosine and sine. Remember that tan x or tan theta is opposite over adjacent from SOHCAHTOA. Sine opposite over hypotenuse, tan opposite over adjacent, or rather cos. Cosine is adjacent over hypotenuse, while tan is opposite over adjacent. And the same tan x, we are told that is equal to sod 3. This sod 3 can be seen as sod 3 over 1. Because if I divide sod 3 by 1, I will still get sod 3. If I have a right angle triangle like this, and my angle x is here, for instance. Remember, the side facing the angle is the opposite. So here is opposite, here is adjacent, while the longest side is hypotenuse. So my opposite is now sod 3. Opposite sod 3. So here is sod 3. Adjacent is 1, so here is 1. But I don't know the hypotenuse. I can call it y. Using Pythagoras theorem, I can now get the value of y. Hence, y squared is equal to sod 3 squared plus 1 squared. Y squared will give me, sod 3 squared means sod 3 times sod 3, which is square root of 9. And square root of 9 is 3. Plus 1 squared is still 1. When I add together, I will get 4. So the value of y is equal to square root of 4. And square root of 4 will give me 2. That is the value of y. So here is now 2. Hence, to get my cos x, you can see that it is adjacent over hypotenuse. Adjacent is 1 over hypotenuse, which is 2. For sine x, it is opposite over hypotenuse. Opposite is sod 3. Hypotenuse is 2. So we are going to put, anywhere I see cos x, I put 1 over 2. If I see sine x, I put sod 3 over 2. So coming here now, cos x, I'll plug in 1 over 2. So I have 1 over 2 to the power of 2 minus sine x is sod 3 all over 2 over sine x again. I'll put sod 3 over 2 to the power of 2 plus cos x, I'll put half. Now, 1 squared is still 1 over 2 squared is 4 minus sod 3 all over 2 over sod 3 squared is square root of 3 times square root of 3, which is square root of 9. And square root of 9 is 3 over 2 squared is 4 plus 1 over 2. Without wasting time here, the LCM of 4 and 2 is 4. 4 divided 4 is 1. 1 times 1, 1 minus 4 divided 2 is 2. 2 times sod 3 is 2 sod 3. I will come down here. The LCM of 4 and 2 is still 4. 4 divided 4 is 1. 1 times 3 is 3 plus 4 divided 2 is 2. 2 times 1 is 2. So this will give me 1 minus 2 sod 3 over 4 divided by, this line here is division. 3 plus 2 is 5 all over 4. Remember, division will be changed to multiplication, and I will turn this fraction upside down. So if I clean here now, I will have that 1 minus 2 sod 3 all over 4 will now multiply, change to times, turn upside down, 4 all over 5. 4 will cancel out. We shall have 1 minus 2 sod 3 all over 5. And this is the answer.